Hello everyone, and thank you for attending today's webinar, UCPE Architecture, Getting Maximum Value Out of a Minimal Footprint, sponsored by ENEA. Before we begin, I wanted to cover a few housekeeping items. On the right-hand side of your screen is the Q&A. If you have any questions during the webcast, you can type your question into the Q&A box and submit your questions to our speakers. All questions will be saved, so if we don't get to answer you, we may follow up via email. At the bottom of your audience console are multiple application widgets you can use. If you have any technical difficulties, please click on the yellow Help widget. Here you can find answers to common questions. A copy of today's slide deck is available for download in the green Resource List widget. At the end of the webinar, we'll ask you for your feedback. A survey will pop open on your screen and will only take 1 minute to complete. Your feedback is extremely helpful. An on-demand version of the webcast will be available about 1 day after the event and can be accessed using the same audience link that was sent to you earlier today. I would now like to turn the event over to our moderator, Heavy Reading Senior Analyst, Ros Rosbaro.
Great. Thanks, Becky. And thanks, everyone, for joining today. Like she said, my name is Ros Rosbaro, and I'm a Principal Analyst at Heavy Reading, and my coverage area is Cloud Infrastructure and Management. I'm joined today by Ulf Bragno, Product Management Director at ENEA, and Jean Seng, VP and General Manager of the Telecom Applications Business Unit at Lanner. I'll start us off with an overview of some of the market conditions and trends around the UCPE market. We'll then do a quick poll question before I hand it over to Ulf to discuss ENEA and its UCPE solution. Jeans will talk about Lanner's involvement with the UCPE market and its work with ENEA. We will have time at the end to take your questions, but please do submit them as we go along. So first, I want to talk about some of the market dynamics driving demand for UCPE. The most important, of course, are the transformations that are underway at CSPs around the world. They are making changes to their network infrastructure and systems to operate more cost-effectively while also generating new sources of revenue. CSPs are increasingly viewing white boxes as a viable alternative to more expensive traditional proprietary network elements. With the emergence of more standardized software APIs, CSPs can now more confidently choose from a wider range of suppliers than they have in the past. One of the areas where white boxes are being deployed first is on the customer premise. And because of the large number of sites, CPEs need to ensure that they have a cost-optimized UCPE platform to make sure that their network services are profitable. This chart here shows what we believe is a reasonable estimate of the acquisition costs of a UCPE platform. You'll see that hardware, including CPU, memory, and storage, makes up nearly half of the cost. The challenge in designing a UCPE platform is to ensure that there is enough processing power to support data plane-heavy VNFs, since enterprise SLAs mandate strict performance in terms of latency and throughput. The VNFs and their associated management software represent about half of the software cost. Virtualization software, such as the hypervisor and the VIM, constitutes a smaller share. And for data plane-heavy VNFs, acceleration software, such as DPDK, might be needed to achieve the needed packet processing performance. And these costs really need to be considered in the context of performance, as, like we said, the enterprises are not going to tolerate any performance degradation. And because CSPs want the UCPE to be under the $1,000 price point of existing network appliances, RAM and memory and the number of cores really need to be minimized. Another consideration that impacts the cost of the infrastructure is the platform boot speed. This attribute is important because it directly impacts service uptime. Additionally, CSPs need to consider virtualized traffic throughput and latency over vSwitch that is supported by the platform. The architectural choices that are made from a hardware perspective will also impact the software that can be run on top of it. And when Ulf takes over, he'll talk a little bit more about how ENEA has addressed each of these areas. Along with those hardware considerations, selecting the right management interface is key to enabling an optimal platform. CSPs must consider the operational issues around CPE, including the platform itself and the VNFs running on that platform. One option for the VIM is OpenStack. Since it was designed to manage data center resources, however, it can be more powerful than is needed in most cases. Using proprietary management solutions is another alternative, but this can be limiting and expensive, negating the benefits of moving to uCPE in the first place. One option that avoids the cost and innovation limitations of the options above that I just mentioned is to use more lightweight solutions such as management over netconf and Yang. Extensions to these well-known tools exist that provide a lightweight alternative for configuration management. uCPE also needs to support some value-added capabilities in addition to the baseline features that I talked about on the previous slides. Service function chaining allows for multiple network services to be linked together in an ordered way. And netconf and Yang can deliver service function chaining during the VNF configuration and deployment process. Deep packet inspection supports more efficient and dynamic service chaining based on tag processing. DPI is important because it allows operators to classify traffic so they can apply firewall and quality of service policies at a more granular level. And lastly, the insights gained from DPI also play an important role in monitoring and troubleshooting network traffic. As I've shown on the earlier slides, UCP platforms need to meet some stringent infrastructure requirements encompassing attributes such as footprint, boot speed, network performance, and core usage. And here we see some of the additional requirements for these platforms. Because Intel and ARM architectures have been optimized for different characteristics, CSPs will likely have a variety of hardware configurations in their portfolio in order to meet their customer requirements. Regardless of the architecture, though, CSPs will want to use as few cores and RAM as is needed to deliver the needed performance. Open source software reduces time to market and reduces the risk of vendor lock-in, while open APIs and interfaces are critical to minimize integration challenges for orchestration and OSS/BSS. A virtualization platform that has optimized the management and orchestration software, as well as the interfaces, enables lower hardware costs since fewer cores and less memory are needed to deliver the necessary performance. And before I hand it over to Ulf, we'll do a quick poll question. So we'd like to know which two of the following requirements for uCPE do you think are most important? Please select two from here. Optimized for low-end white box UCP hardware and not servers. Memory footprint, boot speed, network performance, CPU core usage. The choice of ARM or Intel hardware for cost optimization. Being based on open source and open APIs. Or Mano and interfaces that are optimized for uCPE or vCPE. And while we give our audience members a chance to answer this, I'd like to ask Ulf and Jeans which two do you think are the most important, or what have your customers been telling you about what's most important of those 5 attributes that we've listed there?
Well, I can start here, Ulf here. Because what we've seen is a lot around the memory footprint, the boot speed, and the CPU footprint. It's been a common theme, but maybe primarily actually around the Mano and how you lifecycle manage the platform and the VNFs. There's been a lot of discussions there. So those are the two sort of key areas in our mind.
Yeah, I do know that Mano has been coming up quite a bit in this domain lately. I don't know if Jeans, do you have anything to add to this particular discussion?
So far, no.
Okay, all right. So let's take a look and see what people say. And the audience, half of them say optimize for the low-end white box UCPE hardware, not server software. Looks like second was memory footprint, boot speed, networking performance, and CPU. Multi-architecture not as important. Half of them also say based on open source and open APIs. Not surprising. And just like with the memory and footprint, nano and interfaces optimized for uCPE. So interesting, and I think that sets us up well for Ulf. So please take it away.
Yes, thank you, Ross. So let me start with a quick introduction to NEA for those of you that might not have heard about us before. We're actually been around for quite a long time. We're celebrating 50 years this year in the telecom and software industry. We were founded 50 years ago in Stockholm, Sweden, and since its creation, we have been focusing on embedded software for communication systems in different ways. And today, and actually throughout this period, and even today, we're an independent software vendor. We've grown to roughly 600 employees and roughly around $100 million of revenue, both organically, but through also acquisitions like Cosmos and now latest OpenWave Mobility. Our key customers have been integrating our software, like Ericsson and Nokia have been integrating our software for a long time, and we're deployed in millions of places around the world. And at some point, we did an estimate that around 3 billion users pass their voice and data through our software every day. So that obviously have allowed us to accumulate a lot of expertise when it comes to deploying software, building software solutions for the edge. So if we come back to the topic of this webinar, optimizing CPU architectures, we would leverage that expertise in architecting and building what we call NFV Access, which is a virtualization platform that we have optimized for UCP, and that's what I'm going to talk about here today with you. And what you see here on the screen is 5 sort of key characteristics of this platform. We saw in the poll question that no lock-in is important. Let me talk to you about that. We also saw that open source and open APIs is important too. But there's actually more aspects to this than just these two. So when you talk about zero lock-in or minimizing lock-in, you typically think about using open source, and that's a good start, but it doesn't take you all the way. So we at NEA, we're actually being in an ISV, we can work on this in 4 different ways. So one is obviously basing it on open source. NEA is a key contributor in the open source community, and actually today, right now, we're the main contributor, the #1 contributor in the OpenNFV project. Obviously, using open source standardized interfaces like Netconf and Yang and REST throughout the solution is a given. We do that. So those 2 were covered by the poll questions. But then there's 2 another that are very important, and this is VNF and hardware independence. And hardware independence is important because it allows us to work through partners, best-in-class partners like Lanner, that when we together enable CSPs, operators, enterprises to select the right hardware for the right application. We're not selling our own hardware, not pushing our own agenda. We're just allowing them to pick the right box for the right use case. Might it be Intel, might be ARM, might be large, or might be small. We'll support them all. The same can be said for VNFs. So by, again, being independent, we don't have our own VNFs that we're trying to push. We don't have our own solutions we're trying to sell to achieve lock-in. We can work with any VNF vendor that our customers think makes sense in this case. So those are the 4 things you need to work on really to enable no lock-in. And if you look in the industry, there's not too many companies that actually can address these 4 items for zero lock-in the same way we can. High importance is another key factor, obviously, in this area. And by high performance, I mean both in terms of sort of networking throughput and latency, for example, but also in terms of optimization here. And why is this important? Well, high throughput you can achieve in a data center by throwing tons of cores at the problem. But as we all know, in this space, power and cost-constrained edge, that doesn't work. You need to optimize your solution for your specific use case. And in this case, you need to optimize it for UCP. And by doing that, you can reduce cost because you minimize your core footprint. We'll look at some data for this later. We also talked about the or I call it lightweight lifecycle management interface here. This is something you tend to forget, right? If you get, if you drill down in platform performance and these aspects, you tend to forget the management aspect of the platform. And as it happens, we've seen that this has a major impact on the performance and the memory footprint of the platform. So, for example, going with netcom Yang instead of OpenStack has a very significant impact on the platform footprint. I'm going to show you some numbers on that later. So that was the key characteristics of the platform, the NFV Access platform, but it needs a management entity in order to build a sort of a complete virtualization solution for UCPE. And this is where our UCP Manager comes in. So this is kind of a conceptual picture. And you have on the right-hand side NFV Access and some examples of white boxes that it can be deployed on. In the middle, you have the UCP Manager, which interfaces with NFV Access over netconf. And on the left-hand side, you can see custom OS SPSS systems and NFV orchestrators that the UCP Manager interfaces over REST. So if you look at the NFV Access in this slide, you can see that there's some elements on top of NFV Access, and I'm just going to mention this really quickly. So in here, we have some reference VNF for test and validation. We also have a VNF SDK that VNF vendors can use to accelerate their development. But this is a topic for another webinar. So let's dig into NFV Access in a little bit more detail. So first of all, I think it's important to remember or to highlight the fact that this is not the scaled down sort of multi-purpose enterprise Linux distribution. It has actually been built from the ground up for this specific use case. And this is what enables us to combine low RAM and disk footprint with high performance. So one of the methods we've used to achieve high throughput and low latency in the virtual switching is obviously using DPDK. With SRIV, we can provide very high throughput to VNFs that require this type of acceleration. Another interesting feature or functionality of the platform is our ability to mix virtual machines and container VNFs. And this means that you can, for example, start by deploying a security-centered VNF, like an SD-WAN VNF, for example, in a virtual machine, as a starting point. And later, when you want to start add new services, you can deploy those as containers in the platform. We also have a very capable system management component in the platform that supports FCAPs. And EdgeLink is an interesting component here, and it provides several different lifecycle management interfaces for the platform and for VNFs here. It's netconf, it's REST, it's Docker, and optional OpenStack. We have studied this and seen different combinations, and as we will see on the next slide, the choice here is has an impact on the size and the cost of the platform. Obviously, finally, security is paramount in all applications we've been deployed in. And this platform has been security hardened. We support secure boot, and all communications across the management interface are secured. So let's look at what this sort of brings us in terms of numbers. So some of these numbers are kind of interesting, right? So NFV Access, the platform itself, including the lifecycle management interface I described before, can be compressed down to lower than a gigabyte of RAM and disk footprint. So why is this important? Well, in the UCP use case, memory is actually the most cost-driving component currently. So if you want to minimize cost, you have to minimize the memory footprint of your platform. And here's where the lifecycle management interface or MANO interface becomes important, right? Because if you don't select this interface carefully, you can end up with that component being 10 times larger than the actual platform. Right? So if you look at, for example, OpenStack, and you integrate that without doing any types of optimization, you could be looking at up to 12 gigabytes in terms of memory footprint on the platform. Whereas if you go with a Netcomp Yang solution like we have, you can get that footprint down to a gigabyte or lower. And obviously that directly translates into a cheaper UCP box or a UCP box with more features for the same amount of money. In terms of CPU footprint, we have actually been able to compress or optimize the platform down to a single core. So the bare minimum configuration here is a single core for access and a single core for VNF. That's your minimum. I'll show an example of this at the end of my slide here. And a nice result of this optimization is the boot speed. So it boots extremely quickly. We actually spent some time optimizing this, but it boots extremely quickly, which is in cases where you don't have you cannot afford to deal with HA by duplicating hardware. It depends on the use case, right? There's use cases where this makes sense. There's use cases where it doesn't make sense, and the use cases where it doesn't make sense to duplicate hardware. The boot speed is a way of maintaining SLAs, because if the service goes down, it comes back up very quickly. And I talked about optimization here, and through our optimization, we can achieve 10 gigabits IMIX line rate with very few cores used, and at a very low latency as well. So let's look at our UCP Manager a little bit closer here to sort of give you a picture of the whole solution. And as you can see, the UCP Manager can be deployed in a data center on an OpenStack platform like our own NFV core platform, or it can be deployed natively on a server. So here's a picture of the UCP Manager, and similar to the Access platform, this is not sort of an IT enterprise management agent or an NFV orchestrator that has been compressed to suit the specific use case. It's been built for this use case from the ground up, and it has just the features you need and the interfaces you need to implement SD-WAN or similar applications. So if we start from the bottom and look at the southbound interfaces, this is Netconf and Yang, and this is how we manage the platform. This is how we manage the DNS. This is how we set up the networking. A step up in the core of the engine, we support FCAPs and service function chaining, also done over Netconf. Zero-touch provisioning here is a given feature. And if we look at the northbound APIs, we support REST APIs for NFVO and OSS/BSS integration. If you want to do automation, we support Ansible playbooks. And obviously, we also have the UCP Manager GUI as a way of configuring and controlling the platform. So to wrap it up here, so southbound, it's Netconf and Yang. Northbound, you have a choice of 3 ways of interacting or interfacing with the UCP Manager. So one is the REST APIs, which typically is suitable for NFVO or SSPSS. You have the Ansible for automation, and you have the GUI if you don't need NFVO integration or automation in this case. So with the solution on the market now for a while, we've seen a lot of interest. And it's interesting to see the interest being shifting. We focused on VCPE very early, and we've seen that the VCPE has sort of narrowed down, and the focus within the VCP space is SD-WAN. And that it's interesting. SD-WAN is an interesting technology because it's really SDN technology, but deployed with NFV methods. And we see folks from CSPs, operators, system integrators, and enterprises actually being interested in SD-WAN. So it's a very interesting technology. And we've spent some time building an example of a low-end SD-WAN solution using LANer hardware. So let us look at that on the next slide. So this is an example of what a low-end or entry-level SD-WAN solution would look like using LANer hardware or software, a partner SD-WAN VNF, and our UCP Manager. So here we've used the example of LANer's NCA 1510C, which is Intel Atom Denverton C3308 based 2-core hardware, so very, very low on hardware, capable of low end. On top of this, we run one of these NFV access with EdgeLink Netconf, which is the memory optimized version. On top of NFV access, we have the typical SD-WAN VNF, which does VPN security. It has a firewall, does routing, NATing, and WAN optimization. And NFV access platform and that VNF is managed by UCP Manager. You can automate this with Ansible if you want to. Next to it, we have the SD-WAN controller that does manage the SD-WAN VNF in terms of setting up the actual network connection and so on. So that's sort of the software package. So on the platform side, so NFV access and the SD-WAN VNF, if you look at the footprint, memory-wise and core-wise, this combination takes up to 2 gigs of RAM and 2 cores. And that hits sort of a price point on the market, which is significantly lower than some other solutions we've seen in the market. And yet, being on such small memory and CPU footprint, we can still do a gigabit line rate for all package sizes. So it shows you how making the right decisions in selecting components, in optimizing, in selecting the manual interface and so on, how all making the right decisions enable you to do things like this entry-level SD-WAN solution. So with this, I'd like to hand over to Jeans to have him talk about LANer and their hardware.
Okay, thanks, Wolf, and thanks for the audience joining the webinar. LANer has been a system vendor for over 31 years and deployed network computing platform primarily in ODM model as a major hardware provider in the network security markets. I joined LANer 3 years ago, coming from Appia-Lucent, focusing on the telecom markets and the state of the transition to hardware and the software disaggregation. At LANer, we deployed a broad range of hardware portfolio for NFV, SDN, SD-WAN, and the virtual application. We work with most of the ISV in the market to support the network transition from the purpose-built hardware to the commodity-built platform, for example, the white box CPE. What we have seen the past 2 years in the market is SD-WAN and UCP deployment are moving from the POC, proof of concept, to a real use case deployment as of today. During this transition, we run several challenges, and most critical one for SD-WAN and UCP is the actual cost structure deploying multiple VNF on a single UCPE devices. As outlined in this diagram, typical deployments are in different tiers from small and the medium platforms to the large and extra large platforms for branch office, regional headquarters, and corporate headquarters respectively. The major demand is in the small and the medium platform architecture, what require networking in 1G and 10G modes, as well as LTE and Wi-Fi support for potential zero-touch provisioning. Beyond the UCPE is the BNG, or the broadband network gateway, or multi-access edge sites, where the network aggregation and the compute are taken place primarily for the cloud-based application with low latency requirement and a high access point capability at the central office. UCPE is not only intended for enterprise markets, but also find its space in multiple other vertical markets, such as industry sensors network, as well as IoT connectivity, in a cost-sensitive approach, as seen on the top of this slide diagrams. Due to its size and cost sensitivities, it is crucial to either offload some application to the edge at the central office, or optimize the UCPE itself to be host multiple VNF. Today, there are three types of major CPE deployment in real operations. In the centralized mode, where VNF reside at the edge or broadband network gateways, the distributed mode, where the VNF are primarily located in the CPE devices at the customer premise, and the hybrid modes, where the edge is offering some of the VNF application to the central office data center. The distributed mode is the most resource-intensive operation for deployment on the UCPE, and it is costing management and the control function at the device itself. As a hardware provider for this deployment, we're trying to get the most cost-efficient platform, but in some cases, software just needs a baseline such as resource of CPU cores, memory, and networking. The most cost-incentive commodity in the hardware platform to date are the memory and the CPU. Therefore, optimize the hardware resource for a thinning deployment in the network will help the business case for deployment by need less hardware resource, therefore lowering the platform cost. And it is extremely important for service provider to launch the real business case. In summary, the fact is CPE hardware is still needed regardless which type of deployments. But to what level of complexity is being driven by the software architectures. CPU memory storage and networking component provide the baseline for deployment in a multi-vendor environment, plus the need for LTE and Wi-Fi connectivity. Even if the position is the hardware should be the lowest element in the deployment, it is still needed. So making the best out of the resource available is the challenge. In summary, why we are working with IENA on the UCP applications. We are the hardware platform vendors with scalability and provide solution from the low-end UCP platform all the way up to the edge and the core network infrastructure for NAV, SDN, and UCP deployment for service providers. Beyond the UCP platform, our portfolio provides the baseline for all NAV and SDN deployment needs, regardless at the CPE site or the service provider central office site, which require all high availability features designed into the platforms. So at the end, we, as a lender, we had the experience to address the need for performance and the cost balance. Okay.
Okay, great. Thanks, Jeans. And now we will take some time to answer questions. I see a lot of them have come in. So let me go. Let's see what we have for our first one here. Okay. As for the networking stack and network performance for MPLS, what framework is being used for the Open vSwitch implementation? That's probably a question for Ulf.
Yes, so the vSwitch is OVS-based, and we use DPDK to accelerate the data plane of the vSwitch. I think, Jeans, is there something you want to add here on this question?
No.
Okay,
no.
let me see.
Yeah.
Okay. I'm sorry, Jean, you don't want to add anything to that one?
No.
Okay. Okay, let's see. Next one. We use OpenStack today in our data center and it works fine. Why would it not work in this use case?
Yeah, I guess I can answer that too. I think we in EA we have OpenStack-based platforms. We have something called NFV Core, which is based on OPNFV and OpenStack. We just see in this particular use case, SD-WAN and UCPE, we see some challenges with OpenStack, and one of them is, as I described, is the memory footprint. If you look at just the sort of the core services or the bare minimum compute node services and Neutron and Nova services, we're looking at 400 packages, something like that. And OpenStack, and then depending on how you want to interact with that, whether you want to interact with it as a remote compute node or whether you actually want to translate it into a cloud in a box with a controller also, that dramatically adds on the number of packet list. And this obviously for every packet that comes in that drives footprint. But it also is, as you said in the beginning, Ross, I think OpenStack is great for data center because it enables you to do all the provisioning and the nice scaling, and you have live migration and have all these very nice features. But you really don't need that in this particular use case. So it's great, but it's an overkill, basically. And I think what we're seeing is that you have orchestrators and configuration tools that are able to sort of work with other management interfaces in parallel. If you look at ONAP, for example, and OSM, many of these are multi-VIM. So, I think the future we're looking at is you select the right VIM for the management interface for the right use case.
Right. Okay. That all makes sense to me.
Yeah, I can add a few points.
Sure.
I can add a few points. Yeah. So actually, 2 years ago, then to work with ISB to do a POC for the inter data center SD-WAN applications. At the time, we do use OpenStack, which computer node, controller, and storage will provide full high availability redundancies. But however, when moving this real POC use case to enterprise SD-WAN application, those are large footprints, require more hardware investment to deploy it, even at a branch office site. So that's why the reason we start to work with IENA to provide a lower footprint for real enterprise application. Thanks.
Okay, thanks for that, James. Let's see. How do you characterize uCPE to be able to handle future VNFs? That is, how can you ensure support for SD-WAN tunnels and DPI applications while meeting customer throughput needs?
Can you repeat the question?
Sure. Excuse me. how do you characterize uCPE to be able to handle future VNFs? That is, how can you ensure support for SD-WAN tunnels and DPI applications while meeting customer throughput needs?
Oh, okay. Okay, so it's basically, I think the example I gave with the 1510 books that only had 2 cores, and we used 2 cores, is kind of, it can be realistic in some cases. We know people that are looking for deployments like that. But if, depending on what you want to achieve, I mean, if you want to achieve a buildable platform, we would obviously select something with more cores, maybe 4 or 6 or 8 cores, in order to enable the services being deployed on that particular platform. And in that case, in the 2-core case I'm talking about, obviously there's no vSwitch involved in that case because you don't need it because you only have 1 VNF, right? But if you look at use cases where you have, you want to add additional VNFs, then you need a vSwitch, and this is where sort of the importance of that vSwitch being optimized and the importance of it leveraging DPDK and the combination of DPDK and OVS to be optimal with the hardware. The question around the optimization level of the vSwitch becomes very important as soon as you start wanting to add more VNFs on the device.
Okay, great, thank you. Question for Jeans. Are LAN or uCPE only focused on x86 platforms? Are ARM architectures going to be developed at some time?
Okay, so actually as of today, the majority of UCP use case are 86. However, in last year, we do have do some POC using the ARM architecture by leveraging the CPU from Broadcom and also from Caviant. And we do have some customer group, they are still doing the development for the ARM-based UCP, but the majority to date use case 86.
Okay,
thanks.
Great, thank you. Okay. Can you clarify what you mean with VNF and hardware independence? Is there not implicit dependencies?
Yeah, I think I can. I think that's probably a question for me. So I would say yes, there are dependencies. I mean, saying something else would be not correct. But there's obviously a porting effort involved. I mean, if there's a new hardware that we need to support, there's a level of porting that needs to be done in order to support that particular hardware. But built the platform standardized enough that that porting effort is very low. I think the important thing is the fact that we can work with white box vendors like Lanner to support any type of hardware that the end customer might want to use. I mean, in some cases they have their own hardware that they work with vendors to produce, right? And we have the capability of working with that hardware because we don't sell our own hardware. So there is a dependency, I mean, on the platform technically, but we don't have like a business dependency on the hardware. That's what I mean. And the same for the VNFs. Obviously, every VNF has its own little quirkiness, especially when you look at the sort of SD-WAN type of the firewall VNFs. They all have their own specialty that we need to work with when onboarding them. But what we've seen is that the onboarding effort has been, you know, fairly simple, if not very simple in some cases. But there is a dependency. But the same thing here. I mean, we don't sell our own VNFs, so we can work with any VNF vendor that our customers ask us to work with. So it's the same thing there. On the technical side, yes, there's there is a dependency week, but on the business side, there's no dependency whatsoever for us.
Okay, thank you. Let's see. You mentioned 10G support for uCPE. Are there products being made available that support multiple 10G with uCPE?
I think Jeans, how do you, I know 10G from my market investigations, I know 10G is starting to be standard in Korea, for example, as for fixed line access. We do support that on the devices that does have a 10G line. So Jeans, what's your opinion on 10G and UCP?
Okay, currently in some large corporate headquarters, they do implement 10G for the connectivities. And in the platform that we supply on the 8-ton, 7-ton base, the higher core count, like 12 core or 16 core base NCA 1510s to supply 2-port of 10G in the UCP devices. And the other higher end platforms such as Xeon D base or the single socket or dual socket Xeon base, they do support multiple 10G as UCP platform.
Okay, thanks for that. Let's see. As for the uCPE platform itself, what tools are integrated to reach the optimum performance? That's probably Ulf.
Yeah, I'm thinking here. I wonder if there's a hardware aspect here as well. So yeah, let's start on the software. What tools are integrated? Well, it's open source is interesting because it does provide you with all these alternatives. There's all these versions of different software. You can combine them. Some people have combined them already. Some projects does that and produces a reference implementation, like for example OPNFV. And most of these are not very performance focused. So they will provide you with an integrated platform with some level of performance. I think the magic here is knowing sort of what knobs to turn, which versions of all these. First of all, which open source projects to combine. That's the first one. And the second one, finding the right versions and combining them. And then the third level is knowing what knobs to turn in order to make the combination of these components work well together. So there's some level of, I wouldn't call it black magic, but it's this expertise that our team has, knowing how to tune this. That's one of the tools we're using here. Obviously, besides that, the tools we're using is obviously we're benchmarking or optimizing using our benchmarking architectural environment that we have here. And depending on how you look at it, D3K and SRIOV and so on can also be seen as tools to achieve optimum performance.
Okay, so thanks, Wolf. And from the hardware side, besides DPDPA, in the past 2.5 years, we've seen joint development effort and the effort from the Intel continue to improve the DPDK throughput. So we've seen significant improvement from the short packet performance on the DPDK side. And besides this, in the case a customer has adding some hardware element like quick access chip in the UCP platform as an option, they will sometimes significantly improve the SSL acceleration and the packet transformation between CPU cores and vSwitches. Yeah.
Okay, thanks, James. Got another question related to the software performance. Someone's asking, is the software performance optimizations done with proprietary patches and extensions?
Well, that's a good question. So no. So it kind of ties, and it's almost, I'm going to be careful not to repeat myself here, but it's the knob turning and the sort of, I wouldn't call it black magic, but it's actually very surprising how much performance you can squeeze just by knowing what to optimize and what knobs to turn. So that's what we've done. So there's no proprietary patches or any proprietary code in that part of the base platform in terms of optimizing performance. It's all done by just knowing what to do with the open source components.
Okay, thank you for that. Let me just take a second. I want to make sure I don't forget to get the survey out for people, because we're certainly going to want to have you guys do that at the end. But let me go back to the questions. So we had a few more in here. Let's see. For planning purposes, what is the typical implementation time range for a UCPE NFV embedded solution? Let me see if I got that one.
No, you did. So I'm just thinking time range here. I guess this is actually implementing UCP in, if I'm interpreting it that way, time it takes to actually implement this. I think that's a very difficult question to answer, because you need to know the whole sort of solution that we're looking at. If you look at just Lanner's books, our software, and our management on top of that kind of works right now out of the box, and we have a bunch of DNFs that we know run out of the box in this whole solution, right? So that's available more or less today. I mean, but very quickly we can make that available for evaluation and deployment. But I think and here's where it gets difficult to answer. I mean, for an enterprise, for example, that does want to just connect their branch offices and do like DUI SD-WAN, then we're ready to go almost. I'm simplifying a little bit, but we're good to go with what we have, more or less, right? But if you are a big CSP or an operator that does have core infrastructure in the form of, let's say, an OpenStack deployment in various places in the world, you have already bought into NFV orchestrators or IT admin tools from someone. You want those tools and orchestrators to work with UCP Manager and perhaps even directly with the platform. And that becomes a much bigger project. But what we've been presenting here in this webinar, those components, they can be very quickly integrated and deployed. It's, I think, the integration with the rest of the world, that's where it gets a little bit complicated, and depends on how complicated that level of integration is.
Okay, thanks. I don't know, Gene, did you want to add anything? Nope, go ahead.
Yeah. So in order to shorten the timeline for implementation, actually both Ina and Anna, we are working on, say, an ecosystem partnership approach that we have worked with some VNF on SD-WAN and security with a pre-validated POC done. So it's usually ready to go in most of the enterprise case if they just want to run SD-WAN and with some firewall embedded in the CPE. And for some complicated case, like Wolf mentioned on the service provider side, in the case that they want to implement a hybrid mode UCP deployment case, which means that they integrated the core or the edge central office orchestration together with the UCP orchestration at the customer premise. So it do take some time for them to pre-validate and test. Yeah. Thank you.
Okay. Okay. Thanks for that. Okay. In the case of an upgrade path to a higher performance platform to support more VNFs, does the combination need revalidation? I think this probably has both a hardware and a software component to it.
Exactly. So I think an upgrade, obviously, if the customer is upgrading the hardware to a more powerful hardware, then obviously that means shipping a new device into the field. But as long as that, it would be the same principle as when you get the board for the first time. You sort of plug it in, and through ZTP, you get your configuration automatically deployed, and you're up and running. So I guess some kind of scenario, I guess, is if you're not using, you're trying to shut down the course you don't use or something. But I don't know, Jeans, if you have an opinion here.
Yeah, so in order to offer higher performance, especially on the compute capacity and also the network bandwidth, then to offer a wide range of UCP platforms from different SKU of the 710, Xeon D, and the Xeon solution from Intel chipset. And from ecosystem approach, I think from time to time we will be able to work with IENA to validate the UCP platforms in this platform. So it will be pre-validation done from our ecosystem partner side in order to shorten the real use case deployment at the field.
Exactly. So if not done already, we will validate. And then what we've seen with Daimler hardware is that it's very easy to work with, and it integrates well. And we'll just have that working more or less out of the box.
Okay, thanks for that. Just had one come in. Can you say a few words on UCP integration with open source orchestrators like ONAP, for example? I think maybe this is an Ulf, because that's obviously part of probably what you guys are working on with OPNFV, yeah?
Yeah, we're involved in that. OPNFV has a project working with ONAP. ONAP is part of OPNFV, so we have a couple of other guys in there. So I think what we're looking at here, OSM is also interesting in this context, that they have like a multi-VIM concept where you can have, for example, the UCP Manager act as sort of a plugin to those orchestrators. So that's I think our plan is actually to make a demo available with OSM, which have, I think, come further when it comes to building a working reference platform for this. And the plan is to sort of have the UCP Manager plug into that framework and thus become like, behave like a VIM in the context of the orchestrator.
Okay, great. Thank you. I think we're just about at the top of the hour. Take a quick run through here. Yeah, I think that's, yeah, I think we are set. So I'd like to thank both Ulf and Jens for that information. Thanks everybody for joining, and hope to see you again on a future light reading webinar. Have a good day, everybody.
Bye-bye.